For topic 3, we're going to talk about another way to organize data called a frequency distribution. Okay, along with a frequency distribution, you also have a graph called a histogram, and they go side by side. They're like peas and carrots, they just go together. Okay, so as a definition, we have a frequency distribution is a table that shows how often each data value or each group of values occurs in a data set. A frequency distribution is a way to help organize sets of data so that you can easily see patterns and analyze the data. Okay? So it is similar to a stem and leaf plot in that it is a way to organize data. It helps you get visual understandings of what's going on in your data. What's different with a frequency distribution is you lose the individual data values. Okay. So in a stem and leaf plot, like what we have up here, we can see each individual data item. We break them up by stem, the digits in the tens place, leaf, digits in the ones place. But I can see here that if I have a 7 in the stem spot and a 5 in the leaf spot, that's a data value of 75. Okay. With a frequency distribution, we wouldn't necessarily know each individual data item. We would just know that there were 15 items as in the 70s. We would know that there were 4 items in the 60s, or 5 items in the 50s, or 1 item in the 40s, but we wouldn't know what the actual value of the item was. Okay, so a little different than a stem and leaf plot, but it's the same general idea. It's a way to organize your data. You can still get a lot of information about a data set. You just lose the value of the individual data item. Okay, so let's see here, some additional definitions. So we already know a frequency distribution is a table that shows how often each value or each group of values occurs in a data set, but there's more info that we need to know. There's more definitions, okay? So next up, data. Data is the information or numbers collected for analysis. So each individual data item, same thing with the stem and leaf plot, each individual item would be considered a piece of data, okay? Frequency. This is the number of times a value or group of values appears in the data. It's called a frequency distribution for a reason. We're talking about how frequently a specific item, or in some cases, a group of items, shows up. Okay? Class or interval. So when we talk about a class or an interval, it's a group of values that are placed together in a particular range. Like a lot of times we'll talk about grades. Okay, so if we talk about like exam grades, we're going to look at all the grades that are A's, B's, C's, or D's. So A's would be 90 to 100, B's would be 80 to 89, C's would be 70 to 79, and so forth. So that's the class or the interval. It's just how we're going to break those numbers up. And then we have a lower and an upper class limit. So when you do have intervals of value, so instead of looking at all of the number, or let me not say it that way. Instead of looking at how many times the data item 71 shows up, we may look to see how many times a data item in the 70s shows up. So anything from 70 to 79, how often do we have a data item fit the bill? Okay. So if we have a lower and upper class limit, the lower class limit is the smallest value in that interval, and the upper class limit is the highest value in that interval. Okay. So when we have the lower and upper class limits, it's the smallest and largest values that can belong to a class or an interval. Okay. And then finally, we have a histogram. And a histogram is very, very important. A histogram is the graph of a frequency distribution. Okay, so once you create your frequency distribution, you can then create a graph that goes side by side with it. Okay, so histograms are special types of bar graphs. They're not exactly bar graphs. Okay, in a bar graph, you can envision being in school at, elementary school, middle school, and your teacher would give you like a cup of M&Ms, and you would split your M&Ms by color. So you'd have all of your red M&Ms, your green M&Ms, your yellow M&Ms, your orange M&Ms, your blue M&Ms, your brown M&Ms. You'd count how many of each you had, and then you could draw a bar graph. Similar, but it's not the same thing. In a bar graph, your bars don't touch. In a histogram, your bars absolutely touch. Okay, and it's just a visual representation of what's happening in your frequency distribution. But again, a histogram is a graph of a frequency distribution. Histograms are special bar graphs where the width of the bar indicates the class interval and the height of the bar represents the frequency. So just to make that really clear, the width represents the class interval and the height represents the frequency. Okay, so similar to a bar graph, but not a bar graph. Okay, the bars touch in a histogram. Okay, So let's go ahead and just jump in. I think sometimes when you see a lot of definitions, they don't make a lick of sense, but then once you see the practice behind it, it's not so bad. So that's kind of the case here. All right, so first of all, for example 5, it says create a frequency distribution and histogram for the following data. Okay, so in this first column here, we have the following set of data depicts the age of maximum yearly growth for 35 boys ages 10 to 18. So they tracked these 35 boys from age 10 to 18 and they they measured their height each year. And what this table tells us is which year they grew the most. So at what age did they have the biggest growth spurt? Okay. So we have the age of maximum growth. We have age 10, age 11, age 12, age 13, age 14, age 15, age 16, age 17, and then age 18. And we're going to go through this list of data items and we're going to indicate how often each data item shows up in this list. Okay. So again, just like I did in a previous video, I'm going to go down the columns. That's how I'm going to read through my table. So as I go through this table, I'm going down the columns. Okay. So for the first column, the first number is 12. So I want to put a tick mark by 12, okay? The next number is 14, so I put a tick mark by 14. I have another 12, so 12 gets another tick mark. I have another 14, so 14 gets another tick mark. I have a 13, 13 gets a tick mark. I have a 12, 12 gets a tick mark. I'm going to keep going down each column indicating when a data item shows up. I'll just put a little tick mark in its row in the table, the frequency distribution. So for the next column, we have 14, 17, 15, 13, 16, and 11. Moving on to the next column, we have 13, 13 again, 14, 15, 11, and then 13. For the next column, we have a 14, we have 10, 15, 16, 15, 14. For the next column, we have 16, 13, 15, 15, 12, 14. For the last column, we have 14, 18, 14, 12, and 13. Okay, now here's something that you need to always do. You need to make sure the sum of the frequency matches the number of data items you have. So let's go through and just figure out what we have for each data item. Okay, we're going to figure out the frequency of each data item, and then we're going to add those up and make sure it adds up to 35 because there were 35 data items in this list. Okay, so for 10, we only had one kid have their growth spurt at age 10. Two kids had their growth spurt at age 11. Five had a growth spurt at 12. Seven had a growth spurt when they were 13. Let's see, nine had a growth spurt when they were 14. Six had a growth spurt at 15. Three had a growth spurt at 16. One had a growth spurt at 17. And one had a growth spurt at 17. So let's add up those frequencies really quick and make sure it adds up to 35. So I've got 1 plus 2 plus 5 plus 7 plus 9 plus 6 plus 3 plus 1, and it does add up to 35. So again, if we add up the frequencies, it should add up to the number of data items, and it does. The frequency here adds up to 35, which represents the 35 kids that they were following in this. Okay, now for the histogram. The way you do a histogram is what would be considered the y-axis is going to be the frequency, and what is considered the x-axis is going to be the different intervals or the different classes that we have. Okay, so in this case, we're looking at kids at age 10, 11, 12, 13, 14, 15, 16, 17, and then 18. And I'm just going to title my x-axis age of, and I'm just going to call it age of growth spurt instead of age of maximum growth. Spurt, how do you spell spurt? Let's go with age of maximum growth because it turns out we don't know how to spell. We don't care. So age of maximum growth. I know how to spell those words. Okay. Now, along the y-axis, that's going to represent your frequency. So we're going to go ahead and title the y-axis the frequency. And then let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And that's perfect for our table because we have, at most, we have 9 as a frequency. Okay, so here's what you do. You just build bars, okay? So at age 10, we had one kid have their growth spurt. So we want to draw a bar that goes up one frequency. At 11, we had two kids have a growth spurt. So for 11, we want the bar to go up to a frequency of 2. What is Microsoft trying to do here? There we go. Okay. At 12, we had 5 kids have a growth spurt, so we want to go up to 5. Notice all of my bars are touching and they center around the number they represent. So this bar is centered around the 12 and it has a height of 5. At 13, 7 boys had their growth spurt. At 14, 9 kids had a growth spurt. At 15, we had 6. At 16, we had 3. And then at 17 and 18, we had one kid have a growth spurt. So this right here, this is a histogram, and this is the visual representation of our frequency distribution. And we get some nice information. We can see that the majority of the kids had a growth spurt between 13 and 15. Very few kids had their growth spurts at 11, 12, 17, and 18. Okay, so again, we get some really good visuals here of what's going on with our data set. Okay, moving right along, we can have different types of frequency distributions. So we can have what is called a grouped frequency distribution. And in this case, you use a grouped frequency distribution a lot of times when you have lots and lots and lots of different data items. In the previous example, all of our data items were going to fall between 10 and 18, okay? So we didn't have that many different data items. But down here, we're looking at a group frequency distribution for statistics test scores. So test scores, in theory, could be anywhere from 0 to 100. So you've got 101 possible different scores. You don't want 101 different items in your frequency distribution, okay? Because most of those items wouldn't have any data items show up. So what we'll do is for stuff like this, we will group data items in intervals. We want the intervals to be similar. So that means we want similar upper and lower class limits. Okay. So we want the width of the interval to be basically the same and have similar lower and upper class limits. Now, the first and last interval can sometimes be slightly different. Okay. But in this case, they're identical. Okay. So we have data items from the 40s to the 90s. We can see the lower class limit is always going to be the 0. So like 4, 0, 40, 5, 0, 50, 6, 0, 60, and then 70, and then 80, and then 90. And the upper class limit is always going to be the one that ends in 9. So 49, 59, and then 69, 79, 89, 99. That way, each class or each interval has a similar stop and start point, and they're the same width. Okay, so then somebody went through and they're like, okay, in this class of 40 kids, how many had scores in the 40s? Well, there were 3. We don't know what the scores were, but we know that there were 3 scores in the 40s. We have 6 scores in the 50s. Again, we don't know the individual specific score, but we know there were 6 scores in the 50s. There were 6 scores in the 60s. There were 11 scores in the 70s. 9 scores in the 80s, and then 5 scores in the 90s. And we add up the frequencies to get how many data items there were. Now, I do want to point something out. Notice this N right here. That is something that you will see again in this section, or not in this section, but in this, well, in this section, but in this chapter. N is going to always, for us in this chapter, represent the number of data items. Okay, so anytime you see a lowercase n in this chapter, number of data items is what you should think. Okay, so let's go ahead and build our histogram. Along the x-axis, we're going to put the statistics test scores. So we're going to go test score intervals. And then along the y-axis, we're always going to do the frequency there. Okay, so we have items in the 40s, 50s, 60s, 70s, 80s, and 90s. Now, ordinarily you would type out, or not type out, but you'd write out the full interval like 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. I just don't quite have enough room to do that, okay? But ordinarily you'd leave yourself enough room for that, okay? And then for the frequency, let's go by ones. Now, just be careful here. We do have 11 items in the 70s. So I'm just going to extend this a little bit, and I'm going to say this is 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, so let's start building. Okay, we had 3 items in the 40s. So my bar for the 40s is going to go up to 3. Okay, for the 50s, we have 6. For the 60s, we also had 6 data items fall in the 60s. For the 70s, we had 11. So remember, we had to kind of expand our y-axis a little bit, but that's no big deal. We can do that. Dadgummit. Microsoft tries so hard to make it pretty, and I don't need it that pretty. And then let's see, in the 80s, we had 9 test scores in the 80s. And then we had 5 test scores in the 90s. And there's our frequency distribution. So you can see it's just a visual representation of what's happening in that frequency distribution. Keep in mind, when you have a grouped frequency distribution like this, you lose the individual test scores. We just know there were 3 tests in the 40s, but we don't know what the actual test scores are. This is where this differs from a stem and leaf plot. If this was a stem and leaf plot, we would know we had 3 scores in the 40s, but we would also know exactly what those scores were. So you do lose the individual data items, but you get the same gist of the data set. You understand where you have your surpluses, where you have lots of data items, where you have fewer data items, and things like that. All right, moving along, let's do another one. So you can technically have a frequency distribution where the data items are not numerical, okay? So in this particular case, it says construct a frequency distribution and histogram for the final grades in a pre-calculus class. And in this case, we were not given numerical final grades, we were given letter grades, okay? So the final letter grades are A, B, C, D, F. Okay, so let's go through and figure out the frequency. And again, I'm just going to go, I think this time just to mix it up, let's go across the rows. So I'm going to go across the rows as I fill in my frequency distribution. So each time I see an item, I want to put a tick mark in my frequency distribution. So going along the first row, I have an F. So I put a tick mark by F. I have an A, a tick mark by A, and then a B, and we're just going to keep going along that. So we have F, A, B, B, C, C, B, C, A, and that's the end of the first row. The second row, I have A, C, C, D, C, B, D, C, C, end of the second row. And then the third row just has the 2 items B and C. So let's add up the frequency, the little tick marks for each of these. There were 3 A's, 5 B's, 9 C's, 2 D's, and 1 F. And let's just add them up and make sure everything adds up correctly. That's a good way just to check to make sure you didn't miss a data item. So let's see, we have 3 plus 5 plus 9 plus 2 plus 1. That is 20. And then let's go ahead and add up all the data items in the raw data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're good. All right, now, excuse me, for the frequency distribution, along the x-axis, we'll put the letter grades. And along the y-axis, again, we'll do frequency. So we have 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And then we have A's, B's, C's. Well, I don't need apostrophes, do I? I don't know if I need apostrophes there or not. I need to talk to my English teacher friends. Okay, so we have A's, B's, C's, D's, and F's. There were 3 A's, 5 B's, 9 C's, 2 D's, and 1 F. And there you have it. That's your histogram. So you can see the vast majority of students had B's and C's. Okay. One more example, and then we are done with frequency distributions. We have one more really short video after this. So it says, example 8, construct a grouped frequency distribution and histogram for the following set of final exam scores. So you have seen these numbers before, I think. I don't want to swear to it, but I think you've seen these numbers before. But we have numbers in the 70s, 80s, 90s, 60s, 50s, and 40s, okay? So we're going to group these by 40s, 50s, 60s, 70s, 80s, and 90s, okay? So we have 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and then finally 90 to 99. Let me shrink this just a little bit so everything fits on one screen. There we go. Okay, so I'm going to go through the list of data items. I'll go down the columns again. So every time I get a data item that falls in one of these intervals, I'll put a tick mark, okay? So again, we're going to go down the columns, all right? So let's see, I have 73, 87, 95, 69. First column is done. Next column, I start with 58, then 83, 77, 76. Second column is done. Third column, 68, 89, 75, 77. Third column, we have 75, 52, 81, 71. Fifth column, let's see, we have 94, 99, 75, and 50. Sixth column, wait, 1, 2, 3, 4, 5. Yeah, sixth column, we have 79, 97, 73, 57. Seventh column, we have 96. Let's see, 96, 89, 73, 41. Eighth column, we have 79, 58, 62, 98. And then that last row, we have the weird stragglers, and they are 77, 71, 69, 90, and 75. Okay, so in the 40s, we had one data item in the 40s, 5 in the 50s, we had 4 in the 60s, 15 in the 70s, 5 in the 80s, and 7 in the 90s. And let's just add everything up to make sure we're good. So let's see, we have 1 plus 5 plus 4 plus 15 plus 5 plus 7, and we get 37 data items. Let's double check and make sure things add up as expected. So we have 1, 2, 3, 4 times 8 is 32, 33, 34, 35, 36, 37. So we're good. Okay. So when we build the actual histogram, these were final exam scores. So final exam score intervals, we'll call that the x-axis, frequency for the y-axis. And because we have 15 as one of our frequencies, I'm going to increment each tick mark on the y-axis by 2. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20. And then we had grades in the 40s. Remember, we would ordinarily write 40 to 49 and then 50 to 59. I just don't quite have room. So I'm going to go 40s, 50s, 60s, 70s, 80s, 90s. And there was 1 score in the 40s, 5 scores in the 50s, 4 scores in the 60s, 15 scores in the 70s, 5 scores in the 80s, and 7 scores in the 90s. And there's your frequency distribution. Okay, so just be neat and organized. You could also, in a situation like this, it might be kind of hard to read like where the bars go. So you could put a little number on top here if you needed to. You don't have to, but you could. If you're afraid that I can't read your writing or if I can't read your bar graph, just put that little number there and then there's no question what the frequency is. Okay, so that's it for frequency distributions. Again, you can have a frequency distribution where you don't lose the individual data items, but that's a situation where you don't have that many different data items. Like here we had data items from 10 through 18. You can have the grouped frequency distribution where you do lose the individual data item, but it's because there are so many possible data items. So we group them into intervals that have similar widths. So the same number of numbers in the interval, and you want a similar stopping and stopping point. So like in this case, all of our intervals start with the 0 digit and end with the 9 digit. So 40 to 49, 50 to 59. You could have a frequency distribution for values that are not numerical, like we have here for the letter grades A, B, C, D, F. And then again, we had another group frequency distribution that we built from scratch. Okay, so make sure you understand frequency distributions and histograms.